Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Umar Ashraf as your presenter for today. So I want to present my topic which is ISCSO input-output relational driven sandcat sum optimization for combinatorial testing. So my paper ID is 088 and I'm in course Advanced in Electrical, Electronics and Computer Engineering. So here we first kick off with the background research. So the we had in the software technology has grown rapidly, making a daily task easier and increasing demand. People trust the system to work reliably, but what happened when they fail? So this one we want to tell they have a current issue which is in there's some industrial places that didn't apply the software testing in their own process because of the budget issue and so on. So when they have the issue with this system and they have failed, it failure can cost money, time and lives, which is it also have a problem with the privacy, security and safety. For the left side here, we want to show the some incident that's happened, which is the cybersecurity Malaysian probably massive data that user data leakage and the thousands of flights in US grounded due to IT crash. So that's why we want to tell how important is software testing is, because we want to avoid this big data leakage happening and wants to avoid of this worst thing case possible is happen to our own country. So for SOC testing, we want to tell how wants to explain in the simple term, which is the SOC testing in the software testing is mean we need to try one by one. So as you can see here, Amin's want to buy bread and water. So we had for the input we had the bread and water which is 2, and for the possible value we had 2 with each the type of brand bread type A type B. So at here for the easy testing, positive testing, we test one by one. Bread A, water A is the first choice. Bread A, water B is second choice. Bread B, water A is the third choice. Bread B, water B is the fourth choice. So we can calculate 2 power of 2 equals to 4, which is easier because it requires smaller input. But what happens if we do among 50 type of brand, 60 brand, 7 brand, 70 brand, 7,000 brand? How? So we do only 2 power of 50, which is using bread and water, but 50 type of brand, it can be 1 billion, which is it can create a new problem, which is a infinity output, and this lead to the combinatorial explosion with the calculation that cannot be counted by the output itself. So that's why if you can see here for the comparison, the SL testing, as you can see, we try one by one, right? So at here we will create from the A1, A2, R2, A1, R2, A2, R3, A1, and so on. We follow up test one by one. We got 72 output. For the two-way testing, we just do a simple way, which is we use only two-way sampling. Let's say we had a group GL is a one group, GP is group second group, GR, GA, LP, LR, and follow on for the group. So we just put the group, so we want to avoid the bias among the test case. And once we already do the group itself, we do some deletion. As you can see, there has some tuples there that being deleted because they had the same, right, like the other group. So we had a lot of group here, so we will combine all of it and merge, and it become the total of output produced is 18. So you can see here we had an 18 output is compared to 72 for the bigger input, which is we recommended two-way testing. So for input-output relation here, the input-output relation is defined as connection between the input parameters and resulting system output, in emphasizing how certain combination of input significantly affect system behavior. In ISCSO, the IOR model is used to identify and prioritize this key relationship during task generation, ensuring that the produced test suite captures critical input-output dependencies efficiently. So the right is a figure for the IRTW testing for college advisory system. For the second song optimization, we take the movement itself, which is the they have two movement, which is the exploration and exploitation. So for exploration, the SEN can explore wide desert areas using sensitive hearing to detect a low frequency sounds below 2 kHz, sensing spray, even being sent or from afar. For the exploitation, approaches the second can exploit the moment it will focus sharply and digging with the position using its strong specialized skills. So here with just the second case optimization, we just take the movement by itself from the exploration and exploitation and we try to put inside the T-way testing to do the better result for it. So this is our ISCSO framework, which is a ISCSO actually I is stand for input output relation, SCSO is centered on optimization. For the input parameter setting, we had parameters, values, interaction strength. For the tuple generator, we had to generate the candidates combination. For the test case generator, we apply ISCSO search, which is we apply Sankey sum optimization. For the final test, ensure full T-way coverage. And for the result, ISCSO, this is the result that we got so far. We testing among them, and we also show the result for the Friedman mean and the Wilcoxon test. For the evaluation, this one we just make a simpler data for you guys to understand it. So then we have among the number of test case 12, we can had a percentage of 16.67%. For the among X strategies, the ISCSO performed 35%, ISCSO equal mention 35%, and the ISCSO outperformed 50%. So here we want to tell actually the ISCSO is quite good for being competitive, and why it's outperformed because there's some of strategy among them is already hybridized with another movement or another reinforcement learnings to make it better movement. So that's why ISCSO can still among the original itself, it can beat the other strategies. So the results show that ISCSO achieves superior or equivalent performance in the most configuration, demonstrating its robustness and consistency across different T-way interaction strengths. So for the conclusion and the future work, it can achieve up to 60.67% optimally in a mixed RT configuration. It demonstrates the scalability and strong performance in IOR guided testing, future generation hybrid ISCSO with reinforcement learning for adaptive tuning. So it can we put with hybrid with another reinforcement learning, maybe it can create a better result and maybe it can outperform of other strategy. This is from me. Thank you.